Hi everyone, welcome to another Reasons and Resources video. So in this video I'm going to be talking about reasons and resources for learning to program in Julia. And as always I'll have roughly the same format that I do in the other video as well. I'll go through like my reasons for learning Julia and talk a little bit about how they might be similar to the general reasons why you might want to learn the language. And then we'll move into specific resources, both in terms of the official, if you want to use that term, the official Julia website, and then we'll move out into various other resources, both inspired by what is name checked on the website, but also stuff that I've been made aware of as a result of putting this episode together. So yeah, this falls into the category of languages that I would like to learn. And I always like to differentiate between stuff that I've already dabbled with, stuff that I've used a lot, and stuff that is on my languages of interest list to learn at some point in the future. And this is one of them. So why am I interested in learning it? What's my compelling reason to learn it? Well, I suppose the first thing is that having learned Python and then learn R, and in terms of data science or languages they use for data science, they're the two that I've found cropping up the most when I read through books about data science. So in the vast majority of books that I have on data science, the language that they're always doing the exercises in, doing the manipulation, doing things like machine learning as well, is invariably Python. I have at least one book where the language is R, but I don't think I have any books where Julia is featured. But I am aware that there is almost this sort of, what do you call it, like a trio, is it triumvirate or something like that, a triptych of data science or languages that can be used for data science. Some languages where it's more, they were started off in that area, if you like. So if you think about it, Python is general purpose multi-paradigm language that happens to be really good or the go-to language for data science, for machine learning. Then you have R, which is a little bit more specific to data science. And then you have Julia, which has come along in 2012, so it's 12 years old, which is another multi-paradigm language. It's general purpose, but it has this, certain aspects of it, like fast and productive, that makes it well suited for things like data science, AI, machine learning, simulation modeling, numerical analysis and computational science, those sort of things. So if you're thinking about learning another sort of string to your data science language bow, then Julia, I think, is a good place to go. I would say probably it's best to explore Python and then R first, just because, as you'll see in a moment, they're sort of relative popularity, and then maybe go into Julia. But if you want to dive straight into Julia before the others, that's fine. So as I've said, in amongst all those reasons, one thing is performance, so high performance, which obviously lends itself well to doing very complicated scientific computing. And from what I've read, it's offering speed that is closer to lower level languages. And so again, this idea of, if you're dealing with a computationally intensive task, then, which a lot of scientific computing and data science and machine learning is, then it's a perfect match for that. We'll have a look in a moment, because as I've said, this is a language that I want to learn, so I'm less familiar with it. But I'm going to look through now and see if we can have a look and see an example of the language here. Oh, there we go. So we've got, they does have a REPL, if you're curious. There's roughly what the syntax looks like. And of course, in all of these videos I do, I don't dwell too long on the syntax. They are primarily done just to encourage people to check the language out. But it's always nice on the wiki article to see if there's a sample of code here, and there actually isn't. So we'll see in a moment whether we can have a look at it. But my understanding is that it's both simple and expressive. So it should be easy to learn. And again, you've got this, ease of use of a high-level language with the performance of a language which might be considered to be a bit closer to machine language. The sort of speed you get from using a low-level language. It's supposedly versatile in that, you can use it for other things apart from just data science stuff. And I believe it can be used for web development. But as you explore the language, you're going to find out more about that. And there is interoperability. I always have trouble with that. Interoperability. Yeah, that's it. So that means basically that the language, whatever it is, in this case Julia, can interface with other languages. So you see that often when languages run on like virtual machines, like, if you have, say, the Java virtual machine, Java languages have high interoperability with other languages on the JVM. Same is true of the Beam. So if you've got languages that run on the Beam, the one that the virtual machine that Erlang runs on, then you find that there are other languages that run on the Beam where there's a high degree of interoperability. Now, outside of specific virtual machines, obviously languages generally, because of the way they've been designed and the libraries they have access to and code bases and other things, also will interface with other languages. So you might find if you use Julia, you have interoperability with, say, Python, C, R, those sort of things. So it gives you that flexibility. And as with, I think all the languages we looked at so far, active community, active ecosystem, we'll see how prevalent its use is generally when we look at the results of the Stack Overflow survey, which I was doing these episodes. And with a lot of these communities, they sort of grow, and then you get, I wouldn't say stagnation in them, but with some languages you get like a real explosive growth in the community, and then other languages, there's like stops and starts to some degree, or the community fragments around a certain release maybe, and people go off in their separate areas. So again, it's interesting to see with a language and understand how that community is evolving and growing. So yeah, I'd look into that because I'm not, like I said, I'm not super familiar with Julia, so I wouldn't know currently where on the growth curve Julia is. So I mentioned it's a general purpose programming language, originally designed for numerical technical computing, also useful apparently for low-level systems programming, and as a specification language and various other things. And if you look at this wiki article, which I'll include a link to in the description, as I will do all the other things I'm going to talk about, you can see some of the main features which might act as a reason for you to learn them. Maybe you want to know more about just parallel distributed computing. Maybe you like working with Lisp-like stuff, or maybe you're really interested in metaprogramming facilities, those sort of things, coroutines, and so on. Maybe you're interested in exploring a language that uses dynamic type systems. All of those things are going to affect, I think, your decision whether it's a good reason enough to learn a language. And then we've got another reason, generally beyond what my reasons are, which is, adoption. If you're working as a programmer and you want to know, what languages out there are more popular than others or currently, in favour or growing, then it's quite useful to look and see who learns them. Maybe you're already working within a certain domain and you're curious as to what programming languages might be more suited to that domain. So you can see a list here, and of course this list always changes over time because languages do fall in and out of favour with some organisations. So it has up, here Julia's been used by NASA, FAA, and then we've got Amazon for quantum computing and machine learning, CERN, climate modelling. So you can probably get a feel where if you know a little bit about data science and what sort of things are done, you can probably see why certain organisations which process a lot of data, analyse a lot of data, might be using something like Julia. It's interesting about this as well, embedded hardware. So again, that's something that I've not really explored that much. So yeah, that might be an interesting sort of side quest to go down when I learn Julia, is to see what sort of embedded hardware stuff I can learn. And then this, though, the whole pharmaceutical and drug development. Now, many of you probably know from what I've said in the videos just randomly. I worked originally, back in the day, my first job was working in vitro diagnostics and doing bacterial identification. Now there we had custom built software that was developed in-house. Initially the development that was done in Pascal, and then they moved over to C++. But I've used Visual Basic and Basic, GW Basic, to do bacterial identification mathematics, likelihood calculations, those sort of things. So I have been curious as to whether I could take, the stuff that I've done and refactor it in another language. So Julia might be a good one to experiment with bacterial identification. I don't know yet because I haven't tried it, but again, that might be a reason for me to do it. And then we've got economics, finance and political science. So again, no surprises here. I don't think if you already know about the sort of organisations, the sort of applications that data scientists put to, it's the usual suspects. So let's have a look at the Stack Overflow stuff and see where it sort of fits in terms of, when you ask programmers, developers about what they're using, their popular stuff, as this year's Stack Overflow survey has done for 2024, you also get quite a good view on compelling reasons as to why to learn a language. You'll notice with most popular technologies, I'm not surprised to see it fairly low down the list on here. It's sort of just after Clojure in popularity and above Zig and Fortran. Now, with languages like this that are fairly specialised or are used in a specialised way, should I say, that's not unusual. Also, emerging languages might crop up down here as well. So, but certainly well below some of the things we've been looking at so far. And if you're curious, this is where R is, and Python is right up here. So another reason why you might want to learn them in that order for data science purposes. It gets interesting when we start looking at this one, which is the admired and desired. So it's on here as well, and there's this sort of chasm between desired and admired. You can see there's quite a wide difference here in the percentage. So 61.7% admired, 2.1% desired. I got down the right way this time. When asked the question, which programming, scripting and markup languages have you done extensively, don't work in over the past year, and which do you want to work with in over the past year? So yeah, you can see why that's quite wide based on the previous chart. So if you look at the previous chart, that gives you some clue, I suppose, as to the ballpark percentage figure for the desired, by the looks of things. So a lot more people are admiring the languages and desiring it simply because there's not a lot of call generally for it, I suppose. So while you might admire a language and think, yeah, that's going to go on my list, you don't really feel summoned desiring to learn it because it's not getting in the way of your development as such. And then on the top paying, it's going to be interesting on here. So what you tend to find with this is often newer languages which for whatever reason there's not many, they're in demand relative to the amount of programmers there are. So there might not be a heavily demanded language or most popular language generally, but what you might find is within their pool there aren't many programmers that can program in it, but there is currently a demand. So we've got things from the beam like Erlang, Elixir at the top. Clojure keeps coming up year on year, which Clojure runs on the JVM, I think, if my memory serves me correctly. Actually, we'll be talking about Clojure in the next episode of this, so I'm looking forward to that, because I have dabbled with Clojure and it was fun, actually. Yeah, I did enjoy it. So somewhere here, I do know it's here because I'm sure I saw it. Oh, there it is, yeah. So there we go, Julia. So somewhere between, that's interesting, COBOL and Haskell. Below Fortran. So Fortran's often found alongside it for various reasons. Then we got Lua. So I'm trying to think, what's a big language that a lot of people might be more familiar with? Would you say Go, maybe? Just trying to think, what it's closest to in terms of heavily used languages. And we got Rust there. Yeah. And yeah, you can see actually what with this chart the way it works, because it's top paying. Like I said, it's like supply and demand. So you often find a lot of the super popular languages that everybody learns are down the bottom here in terms of compensation, because there's loads of people that know the language. I don't know if I did it. I should dig it out again. I once did a sort of chart. I think it was some sort of pivot table. I'll have to see if I can find it, which sort of looked at most popular versus top paying. And in fact, yeah, I've done spreadsheets on that as well. Yeah, I'm sure you've seen this spreadsheet before this one. So I've gone through stuff like this. And you can sort of work out, which ones come out over time on both lists. And you find it's things like Go, Ruby and Swift. Yep. So moving on to specific resources, quite a lot of the links are going to be to stuff on the Julia website, because it's like other programming language you looked at so far. The main source is the main source. There's a lot of stuff on there that you can access. So I'll include a link to the main website. I'll include a deeper link so it's easier to get to the documentation page, because it is worth reading. I know a lot of people don't like reading documentation, but I think at some point in learning a language, it is a good idea to look at the documentation. And even this bit is quite nice if you're still teetering on the edge about learning it, because there's a little bit of how it compares to other language, what makes Julia, advantages, those sort of things. So yeah, don't be afraid to check out the documentation for a language. Getting started, so that's always very useful. So I'll include a link to that, how you install it, Yeah, download, install it. And then once you've got it installed, it's really up to you how you want to, whether you want to use it minimally or whether you want to integrate it into your favorite editor or, the IDE you use for other things. As you know, I tend to do the same thing where I download the programming language. I then check that it runs, the REPL runs, and it runs at least at the command line. So I just put together a very basic text file with hello world or counting from 1 to 10. Just make sure it works at the command line, regardless of where I might be. And then what I normally do is go into Visual Studio Code, add in the code highlighters and any additional things that might be useful for the language, and then make sure that it works and I can run the interpreter or compiler for the different languages, what I'm using, at the command line inside of Visual Studio Code. But you can do similar things in other text editors or IDEs. So yeah, I'll include a link to that. There's a link to the community page. So if you're interested in exploring that, seeing what the community's like, it's always useful to get a feel for what the code base currently is like, what sort of questions keep coming up, what chat resources there are, what forums there are for, those people starting out or those people who are slightly further along the learning curve. There's a useful Get Started Learning page. So we've got the Julia Academy exorcism, which you can check out, the manual, which is the Getting Started guide. And there you go, so you can go through there. And there's also a page on MOOCs, Teaching Julia, in Learn or a section. So I've included that so you can check it out. I've not dug too deep into these yet, so I'm not sure which ones are free and which ones aren't. But I just wanted to include them, because that's something I'm going to look at, obviously, once I start learning. There's some go-to stuff. I mean, I'll probably end up buying a book on Julia, because as it's become apparent, books are my favourite thing to look at, and we'll come on to online resources in a moment, so you don't have to necessarily buy a physical book if you don't want to. But before we do that, just a few video resources on YouTube. So there's the Exorcism Brief Introduction to Julia, which you can access through the Exorcism site as well, but I'll include a link to that. We've got the Julia Programming Language channel, which is super useful. So lots of really handy stuff there about using the language. And other subjects around that. We've got an interview on YouTube on the Context Free channel with the Julia Language co-founders. So I was trying to track down at least one video in these episodes where there's some sort of interview or some sort of keynote speech with the founders, co-founders of the languages I talk about. And then we've got the Talk Julia podcast. So, of course, you could get to this on YouTube. I'm assuming there's another way through, maybe, if you're curious. But yeah, we've got quite a... Now, with this, remember, yeah, this is one where they didn't maintain the podcast beyond, 2 years ago. So it is older stuff, but sometimes it's interesting to see. And I'm sure if you search through your podcatcher, you might be able to find other podcasts. But yeah, it looks like it's, a couple of years old. So I'll give you a nice overview of the language. Looks like the episodes are, half an hour to an hour long. So yeah, not too egregious, not like my videos. And then we've got a couple of book resources, but online. So we've got Think Julia, How to Think Like a Computer Scientist. So I'll include a link to that. And we've got, from the Julia Data Science website, we have this, which is Data Science Using Julia. And if you click on that, that takes you to the PDF version, which you can download. And then there's also source code at GitHub. And then finally, if like me, you like to dabble around on exorcism, just try out doing some of the sort of classic challenges, because a lot of the exercises are always the same, the usual suspects, but it's useful to see how they manifest themselves in the different languages. Then check out exorcism. It's constantly evolving. So hopefully that was helpful. It certainly helped me in terms of putting this together, making me aware of what's out there when I finally take the plunge, whenever that's going to be in 2025, and actually start dabbling in the language. I've got a rather long list, and it's getting longer, of languages that I want to mess around with. I'll also include a link to the website I've put together on WordPress called Programming Polyglot, which will feature, and well, it actually does currently feature Julia in one of the sections there, so you can check that out as well. Thanks once again for watching. Bye for now, and I will catch you in a future video.